Hello everyone, welcome back to the Fabrication Shop. Today we'll be looking at creating a 3D printed nose cone that's going to better match the original nose cone that came on the Scrambler rocket. Now if you're new to our channel, we want to encourage you to subscribe and hit the bell so that you'll be notified when we drop our next video. I want to start by looking at the differences between the two nose cones. The original Scrambler nose cone was the BNC-65AF. Now that's a balsa nose cone that has an ellipsoidal shape and it's 102 millimeters in length. Now the nose cone that comes in the Green Eggs kit is plastic. It's also longer at 135 millimeters. So to better match the look of the original Scrambler, we're going to 3D print a nose cone. If you don't have a 3D printer, or if you don't want to go through the process, the nose cone that comes with the Green Eggs kit is going to work just fine. To get the profile for our Scrambler nose cone, we're going to turn to OpenRocket. Open the software and then select the nose cone option. When the Choose Component Preset dialog box is displayed, scroll down to the Estes BNC-65AF entry. When you click on it, it should be added to the main screen in OpenRocket. To do our print, we are going to separate the nose cone into two pieces. The nose cone itself, and then the shoulder as a second part, and both pieces will be printed separately. We want to export the nose cone without the shoulder, so we need to make some changes in OpenRocket. Click on the shoulder tab and change the length to 0. That eliminates the shoulder. Now go back and adjust the thickness of the nose cone. For our 3D print, we plan on using a 2-wall thickness setting in Cura. Cura shows that the default line width is 0.4 millimeters. Based on this, we'll set the wall thickness in OpenRocket to 0.8 millimeters. Also, make sure that the filled box is unchecked. We can now export the nose cone as an OBJ or object file. Right-click on the nose cone in OpenRocket and select Export as OBJ in the pop-up menu. Save the file, making sure you have the Remove Origin Offset box checked. To print the nose cone, we're going to take the file we just saved and we're going to import it into our slicer. I tend to use Cura. I'm using a 0.12 millimeter quality setting and will add a brim to the base so it will stick to the build plate a lot better. I found that I don't need any supports for this print. After slicing, Cura indicated it would take about 2.5 hours to complete the print. I saved the slice file as a G-code, loaded some white filament into my Ender 3, and then started printing. Next, we'll create the shoulder in Tinkercad. I waited until the nose cone was complete before I started to design the shoulder. This allowed me to measure the inside diameter of the nose cone instead of relying on calculating the diameter. Sometimes the two are not the same, and by performing the actual measurements, I can make sure the shoulder ring will fit. To make the shoulder, we're going to use 3 cylinders. The outer cylinder will fit into the clear payload tube, and we know that has an inside diameter of 44.45 millimeters. We're going to set the height at 19 millimeters. This matches the shoulder height for the original nose cone. The second cylinder will fit inside the nose cone, which has a measured inside diameter of 43.25 millimeters. And we're going to set the height to 27 millimeters. The third cylinder will be 42 millimeters in diameter and 30 millimeters tall. We're going to use the whole cylinder here. From a top view, center all 3 cylinders using the alignment tool in Tinkercad. Group all 3 cylinders and you should have a nice shoulder ready to be exported. Click on the export button in Tinkercad and save the STL file. Like we did with the nose cone, take the file you just saved and import it into your slicer. Since the shoulder is not in the airflow, I used a 0.2 quality setting and again added a brim to the base. No need for supports for this print either. Cura indicated it would take about 40 minutes to complete. Save the slice file as a G-code. Remove the white filament from your printer and load in some black filament and then print the shoulder. While the shoulder is printing, I did a small bit of repair work to the nose cone itself. At the very top of the nose cone, you will observe that there are some gaps where the filament didn't quite come together. We're going to use a small amount of plastic putty and we're going to fill the inside of the nose cone and push it through to fill up these gaps. Now this is the same type of plastic putty you would use when you're building plastic models and you want to fill gaps. Once the putty is dry, go ahead and sand it smooth. With the nose cone repair complete, I sprayed the nose cone with Rust-Oleum filler primer. This is going to help fill the small lines that are a byproduct of the 3D printing. Once the primer is dry, we sand the nose cone smooth. Depending on the quality of the print, it may take a couple coats of spraying filler primer and sanding to get a smooth surface. The original nose cone on the Scrambler was orange, and we're going to do the same thing here. We'll use a paper towel tube to hold the nose cone while we spray paint it. Then set it aside to dry. Since we use black filament on the shoulder, there's no need to paint it, as this will match the original Scrambler. Once everything is dry, we use 5-minute epoxy to adhere the shoulder to the nose cone. And that completes the assembly of the nose cone. This also completes this episode. If you've enjoyed this video and you like what we're doing here, please click on the like and subscribe buttons. If you hit the bell, you'll be notified when we drop our next video. So until next time, wishing you all the best and take care.